What is a naval architect?
Yeah, I'm glad you asked that instead of came out with a cliche joke about belly buttons because I just get sick of listening to that one. Okay, naval architects consider everything that floats on the sea. So you've got the structure, you've got the dynamics of that structure, the stability of it on water, or even some, under the water. If you talk about submarines, all the layout and the hydrodynamics concerning that as well. So it's actually quite a broad spectrum. I guess you could say I had an epiphany, which was if I'm going to be self-employed, I can do it a whole lot better than these guys can do it. That's where the seed grew for A Squared, because I just thought this company that I'm contracting into, their values didn't match mine. Their ideas about governance didn't match mine. And the whole way of developing people certainly wasn't my idea of how to develop an engineer. I wasn't born to work in a big company because I guess I like to make things happen and I like to achieve things. And you're not going to do that in a big company. I don't think we do typical
Okay.
because our ethos and our vision is just to do cool stuff. That's pretty simple. Do engineering that we're proud of. And the vision for me for the next 5 years as we grow is just to bring a bunch of really clever boys and girls together around whiteboards and in front of good software and do cool stuff for people. That's all
Mhm.
we want to do. As we've progressed and we've invested in Apex, I think I've mentioned to you in the past, I think it was like going from skateboard to a Ferrari in one jump. The innovative tools in Apex that I absolutely love. There's no way I'd go back to anything else.
Mm.
To the speed at which we can generate geometry and mesh, high quality geometry and mesh,
Mm.
and know that it's properly connected,
Mm.
and know that the mesh is a very high quality before you even get to trying to get it to run.
Mm.
That's the game changer for us.
Well,
I've
haven't
been
you?
I've been through some of the training. The training's fantastic that you do. Just a little plug for you there.
We can edit that bit out. Don't worry.
Yeah, yeah,
You
yeah.
make me blush.
As endorsed by A Squared. This is the hardest but most fun thing I've ever done in my life, and it's true. The troughs, when you get in a trough, it's pretty low, but counteracted by the highs are just astronomical.
Yeah, no, that's really good. That's really good. Andrew Robson is a naval architect and structural engineer at H Squared Engineering, a design and development consultancy he founded in 2018. Andy has a wealth of experience working in the marine, offshore, and oil and gas sectors and has helped to develop some of the largest vessels and offshore structures in use today. Andy's prior experience across these sectors has given him the ideal foundation in growing his own business by fostering values where all colleagues can develop, supporting clients in an agile and forward-thinking manner, and, in his own words, just doing cool engineering stuff that we can all be proud of. In our conversation, we spoke about the inertia seen in large organisations, the amazing work that A Squared have been involved with, from super-yacht development to a drill support rig for one of the biggest holes ever drilled in the seabed, to the use of contemporary FEA software and how it has revolutionized the way in which A Squared can help their clients. Cool. Okay, Andy. Good to
Hi,
see you today.
and you.
Yeah. Well, I often I usually start by giving the viewers an understanding of where we are in the world. So you're up in the northeast of the UK, aren't you?
Yes, that's correct. We are just outside of Newcastle upon Tyne, England.
Yeah. Okay. Okay. I was going to give a little intro to who you are and what you do, but I thought it's probably best coming from you. So
Okay.
I don't know if you want to run through maybe some of your background in terms of your career and
Sure.
how the
Okay.
last few years have looked for you.
So, where do we start? My name's Andy Robson. I'm the managing director of A Squared Engineering. We are a small engineering consultancy in the northeast of England. What am I? I'm a naval architect. I've been in the industry over 30 years. I've worked in ship repair, ship conversion, vessel upgrades, shipbuilding, both at the sharp end and behind a computer screen at a desk doing hard sums, as well as getting beaten up by welders on a regular basis. Uh, that's what we do.
Yeah. Okay. So the bulk of your career has been marine, offshore.
Mostly marine,
Okay.
offshore, oil and gas, renewables, a little bit of nuclear, and quite a lot of defense as well.
Okay. Okay. So correct me if I'm wrong, but big, heavy fabricated
That's right. Yeah.
steel structure.
That's
Yeah.
correct. Yeah. Bigger
So
the better.
so not a lot of thin-walled carbon fiber layups and stuff like that.
Absolutely none whatsoever.
That's pretty refreshing. That is for me coming from
Yeah.
an aerospace background. Just
Yeah.
great big chunks of steel. That's
Yeah. We don't muck around. We just make them big. So
that's pretty cool. That is. Okay, so yeah, again, we've known each other for quite some time.
we have. Yes.
Discussed various things that you've been involved with.
Yeah.
So A squared, you're up in the northeast.
Yep.
Is there much of a marine industry or marine stroke offshore industry in the northeast? Then how does that look?
There is. It's getting quite a resurgence due to offshore renewables. Obviously, there's historically, there's been a very strong shipbuilding, ship repair pedigree to the region that, sadly has died away. But what is left in its wake, there was the oil and gas industry. So there's a lot of businesses and consultancies sprung up around that. And then as we transition into a greener future, they are starting to make their transition. And there's some fantastic, engineering businesses to me, EPC companies and some consultancies up here. Yeah.
Okay. So you talk about the renewable industry. So presumably, I mean, what's that? Turbines out at sea, then, is it, or wave generation? What kind of stuff?
It's fixed base offshore wind. That's there's an awful lot of work going on with installation. What's required for installation? So you've got a lot of companies feeding into that who build big bits of kit, and it's like really, really interesting, quite bespoke stuff.
Yeah. Okay. And of course you mentioned you got your fixed equipment, as it were.
Yeah.
I mean, designing that in its operational state is one aspect of things, isn't it? But then,
sure,
of course, you've got another consideration of how do you get that equipment, well, to site or to sea or whatever you call it.
Well, exactly. And you take a look at this. You thought offshore oil and gas was big, and then you see some of the stuff that's going on for the installation of fixed turbine foundations, and it is monstrous. The numbers just keep getting bigger and bigger as turbine nacelles get bigger. This stuff is just getting enormous. And there's talk in the industry now. I think we're probably getting towards the peak of the size of the kit that we're having to use, because you just can't keep building bigger ships for it.
Okay. So the movement is the constraining factor.
Yeah.
The size of the equipment you can work with.
Yeah. I mean, good goodness, these turbines are absolutely enormous. You're talking a blade length of about over 100 meters per blade now. So the swept radius is absolutely colossal, and the infrastructure you need to support all of that and to install all of that it's mind-boggling.
Yeah. Okay. And presumably those turbines at sea are bigger than the ones on land. Then
orders of magnitude bigger.
Oh, are they?
Yeah. Oh, yeah. Yeah. It's just the scale just terrifies me. It's absolutely enormous, and the infrastructure to support all of that installation work is just incredible.
Yeah. Okay. So yeah, like you said, that some of the shipbuilding industry has gone away. In terms of carrying passengers, carrying cargo, and what have you.
Yeah.
But in its place, the sort of research, or the growth of renewables, stuff happening at sea, and below the sea has sort of given rise to this growth in the industry.
The skills are all very similar, whether it's shipbuilding or whether you're building things that go in the water to install wind turbines. Steel is steel at the end of the day. The only thing that changes is the environment you're putting it in and the standards you're working to. And big machines are just big machines. That's all it is, really.
Yeah. Gotcha. Cool. Okay. So thank you for that. So your career's progressed, working for various companies in a structural engineer, naval architect. I mean, what actually that was a question I was going to ask. What is a naval architect?
Yeah, I'm glad you asked that instead of came out with a cliche joke about belly buttons, because I just get sick of listening to that one. Okay, naval architects consider everything that floats on the sea. So you've got the structure, you've got the dynamics of that structure, and sort of the movement of it, the stability of it on water, or even some, under the water, if you can talk about submarines, and all the layout and the hydrodynamics concerning that as well. So it's actually quite a broad spectrum.
Yeah. Okay. So would you class yourself as a structural engineer within naval architecture?
Yes. Yeah.
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 Okay.
Yeah.
Okay. Okay.
Because it is a broad spectrum. Not only does it cover structures, it covers hydrodynamics, and that's just a whole other subject on its own.
Yeah.
And
Yeah.
that really wasn't my strong subject.
Yeah. Okay. And obviously we'll talk about simulation, as we go. But
Yeah.
obviously, FEA is structure and
Yeah.
CFD is fluid. So
Yeah.
there's a distinction there, isn't there? Straight away
Yeah. Yeah. Yeah.
in
Yeah.
terms of the technology that people are using.
Yeah.
Okay. Okay. Cool. Right. So I'm going to ask again. I've got a list of questions here that we've been through before we start the call.
Yeah.
What was the impetus and the motivation
Mhm.
to start your own company? Can you give us some background?
Wow, that's a good question. Where do I start? I think it's always been in me. For most of my career, it's been in the back of my mind. The opportunity and having the guts to go and do it took a long time.
Okay.
And I think what pushed me to do it was I was made redundant in 2015, and I had no choice. I had to go contracting,
Yeah.
and I ended up working for a very large company, and I guess you could say I had an epiphany, which was, hell, if I'm going to be self-employed, I can do it a whole lot better than these guys can do it.
Hmm.
And that's where the seed grew for A Squared, because I just thought this company that I'm contracting into, their values didn't match mine. Their ideas about governance didn't match mine.
Hmm.
And the whole way of developing people certainly wasn't my idea of how to develop an engineer. And I thought, no, we can do this a lot better.
Hmm. Okay. Okay. I mean, when you talk about the size of a company, I mean, how many people would you have in the organization, locally in terms of where you were working?
Where I was working at the time, you were talking thousands.
Thousands of people.
Hmm.
Yeah. Okay. Okay. And something I've thought about myself, and
Hmm.
similar in terms of setting Evotech up.
Yeah.
The way things have gone. I've seen big companies
Hmm.
with massive amounts of inertia,
Yeah.
both in terms of project development
Yeah.
methods, the ability to want to bring in new ideas.
Yeah, you're absolutely right. That's a really big part of it. And you're absolutely spot on there, Steph, because you just cannot effect change very easily. When you see something in a big company that needs to be changed, and everybody knows it needs to be changed, everybody agrees it needs to be changed, but the actual impetus and the drive required to make that change happen it's like running through treacle every single day, and
Mm,
that's just not what I'm about. And that's
yeah,
one of the facets of A Squared that I like, having that small business. We're all agreed we're going to make the change, right? Let's go and do it because we're ready to go and do it.
yeah, yeah, yeah,
I wasn't born to work in a big company, because I'm just like I guess it's just I like to make things happen and I like to achieve things,
yeah.
and you're not going to do that in a big company. The other thing that didn't occur to me until only actually a couple of years ago is this: when you start out as a young enthusiastic engineer, and you see all the company chat in your induction process about the companies have these values and we're looking for you to uphold these values and whatever. Certainly there was a large part in my career going, yeah, whatever. I really wasn't that interested in that side of thing. And it's only since I set A Squared up, actually company values are really important, and we take them very, very seriously.
Mm,
And what it also occurred to me was it's very difficult, the bigger your company grows, to make sure that everybody's got the same values as you. And so when you factor that up into an organization of thousands of people, you know darn well that the directors there probably don't actually have those values, and you can bet your bottom dollar that 100% of the people in that company do not have those values either. It's very, those values become distilled, and it's very, very difficult to make sure everybody adheres to it. Different case altogether with someone like our companies, because we've got total control over that, and we've got total control over whoever comes in this company, and if those values don't fit, well, they're not going to fit well with this company.
But I mean, being specific about those values, are you suggesting then that you perhaps care more?
Yeah.
Okay.
Yeah. If I didn't care, I wouldn't be doing this.
Yeah. Okay. So I mean that's going to happen as a byproduct of being in a smaller company, anyways. In the sense that if you're not pulling your weight, you're not getting the work done. You're delivering a quality outcome to the client or to a manager or whatever.
Yeah, exactly.
You're going to get found out straight away, aren't you?
It's pretty darn evident in a small company. There is no hiding place here.
Yeah. Whereas in a larger organization, I mean, my background's from an industry perspective very different, aerospace, but I've worked in similarly large companies.
Yeah.
And I'm always fascinated by how people stay motivated in those companies, because I'm probably generalizing massively, but there's deadwood in there. There's people who don't care. There's people who just want to turn up, go home, get paid, and then you do get some people that are absolutely motivated and dynamic and want to do a good job. Like you say, when that's distilled down to a smaller company, you've got to be like that, haven't you?
And also, the other thing going on here is that in a big company, it's so easy to be pigeonholed into one small specific area of knowledge or set of tasks that you're given to do, and that naturally happens in a huge company. Well, guess what? In a small company, it's not, and everybody has to do a bit of everything and be involved and be absolutely engaged in all of it. Because again, there's just no hiding place. We have to all share the load on this.
Yeah. Gotcha. Yeah. Okay. So how long have you been running A Squared then?
We've been going since we formed the company in 2018. We only really got going in January 2019. So 5 and a bit years.
Yeah. Okay. And a great big dollop of COVID in the middle of that.
Actually, COVID didn't hit us too badly because we were already set up to work remotely. That was the whole idea of the company in the first place. So we were very lucky that the transition through COVID wasn't actually that bad. It was actually it was difficult to engage with other clients and new clients, but somehow we made it through.
Well, again, it's a bit of a cliche, isn't it? But it's helped massively with remote working, hasn't it? I mean, what we're doing here, Zoom call, totally natural, isn't it?
Well, hell, you and I have known each other for I don't know how many years, Steph, but we've never actually physically met. But I would say the last two years we've worked more together than we ever have done, and we work very well together, and still we've never met. We've just never got around to it.
You do realize I'm 8'3", you know that, don't you?
So it's okay. I'm 4'2", mate.
I'm not 8'3".
I'm not 4'2". It's all right.
Good stuff. Okay, so I mean, I know some of the background of the work that you've been doing. From a couple of projects I've looked at with you. But what's the typical type of project that you get involved with then?
Oh goodness,
is typical not a word you could use?
I don't think we do typical because our ethos and our vision is just to do cool stuff. That's pretty simple. Do engineering that we're proud of and do cool stuff. And the vision for me for the next 5 years as we grow is just to bring a bunch of really clever boys and girls together around whiteboards and in front of good software and do cool stuff for people. That's all we want to do. And so it really doesn't matter whether it's oil and gas, whether it's offshore renewables, whether it's commercial marine or super yachts. I don't care. All right. What I want to see is clever people adding value for clients
Mm.
and doing cool stuff for people.
Yeah. Okay. I mean, I have seen certainly from an aerospace perspective is that
Mm.
some of the sort of smaller offload companies
Yeah.
end up taking the drudge
Yeah.
that the big company just hasn't got capacity for,
Yeah.
filling a room with however many people, just doing that handle turning exercise for the
Yeah.
client and shipping the
Yeah.
numbers
Yeah.
back.
Yeah.
So
Yeah.
you're pretty different to that, then, aren't you?
Well, look, you've got to have a mix of both. All right. We have to accept that there's a certain amount of drudge, which is going to be brackets and other slightly less interesting stuff.
Yeah.
All right. Because that pays the bills. We can't always be rock stars 100% of the time. All right. You've got to do that, but you've got to maintain interest and allow people to grow and push themselves a bit.
Hmm.
You've got to take on the cool stuff as well. And the ultimate aim is to do more of the cool stuff, less of the drudge, but it goes with the territory.
Yeah. Okay. And especially, again, we'll talk about this. If you're looking to grow your business,
Yeah,
got to find your way through the market to the stuff you want to be doing. But like you
exactly.
say, you've got to pay the bills and you've got to take the
Yeah,
opportunities where you can. Yeah. Okay.
yeah,
Okay.
yeah.
Okay. Cool. All right. So cool stuff. I know you've got lots of cool stuff that you've been doing.
Yep.
Well, I don't know. Should we spend half an hour talking about bracket design? Maybe.
Nah.
um, cool. Okay. So, well, there's a couple of things you mentioned to me, but go on, what are some good examples of things that get you up in the morning?
Oh, right. Great examples that got me up in the morning. Right. We're going to talk about FE, aren't we? We're going to talk about FE.
Well, we can do, but if it's more general to start off with, then
Okay, right. What gets me out of bed in the morning? Right. Okay, let's talk general first of all.
yeah, okay,
All right. Um, I love the game. I love the game of growing this business. I just, it gives me some absolutely massive highs. The
okay,
whole idea of going out to meet clients, begin to understand what they want, and then help them to, taking that a step further and understanding what their real exam question is, because
yeah,
they don't always know what it is,
yeah,
and then get them to the point where we've actually added value is just fun. And I don't care whether that's like a chassis problem on a jetting tool or whether that's, something for installing something big on a super yacht. It doesn't matter. What's fun is really bringing people together around a whiteboard going, is this really what they want? What's the concept? How are we going to get past this? And then understanding that exam question and then arriving at the solution that gives value for the client. That whole thing of bringing people together to solve problems is just, that's what gets me out of bed.
mm, yeah, okay. I mean that's fascinating, isn't it? No, you
Yeah.
can develop your skill set, develop the people around you
Yeah.
to be in a sort of reactive, agile,
Yeah.
working in that way that you
Yeah.
can go in and scope out projects and help your clients in that manner.
Well, we tend not to let people loose on doing any sums or any bloomin' FE. That's pointless. All right. You've got to understand the question first.
Yeah.
All right. And that often is just stand in front of that whiteboard. Tell me what you think the problem is. Do we actually fully understand this problem? Because if we don't, there's no point going back to the client. We're going to look like idiots and we're going to cost somebody a lot of money.
Mm, mm,
All right. So if you can explain it in a couple of sentences with a couple of simple scribbly pictures on a whiteboard, then we know we understand the problem. We
mm,
understand what the question is, and then we can go back and talk properly to the client then.
mm. I think I remember a phrase you used. What was it? Designed by intuition.
Check by calculation.
Yeah, that was it. Yeah.
Yeah,
Yeah.
one of my famous lines from LinkedIn.
Oh, is it? Yeah. Okay.
Yeah. So more than one person has actually come up to me recently and said, "Do you know what? That's actually ended up on our whiteboard in the office." Which is just like, wow, we've never actually met before, but that's quite a compliment.
Yeah. No, that stuck with me
Yeah,
definitely.
yeah,
Okay, so if we think about the actual projects themselves that you've been doing,
yeah,
I mean,
yeah,
we did talk about the world's biggest hole. I mean, I know that could be
yeah.
that could mean lots of things, couldn't it? But
Well, yeah. Let's just this is a family show, so
yeah, yeah. I mean, can you talk around that then?
yeah, we can talk a little bit about
Yeah.
that. So this it's still ongoing. This is one of the biggest subsea drilling templates ever built in the world ever.
Okay.
It drills holes in the seabed of the order of in excess of 9 meters diameter. So the infrastructure surrounding that to achieve that was just phenomenal, and we did about that much contributed to it, but I'm very proud that we did.
What? Okay. First question. What? Why do you need a 9 meter diameter hole in the
Okay,
bed?
right. Okay, so right. So the background to this is related to fixed bottom offshore wind. All right, and there's a number of environmental factors surrounding why they wanted to do it this way. uh, Principally to do with noise generation with hammering piles into the seabed.
Okay.
All right. So it's related to the proximity to the shore and sort of human population on the shoreline, but it's also related to minimizing the environmental noise impact subsea for wildlife subsea, such as dolphins and other marine
Yeah.
animals.
Yeah.
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 Yeah. So what they're planning to do is they're going to drill a whole series of these holes, backfill them with sand, and then use vibro hammers to hammer in the piles. And I believe there's a lot less noise involved in this.
Oh, okay. So is it almost like a dampening
Yeah,
mechanism on the seabed?
yeah, yeah.
Okay.
So what they've got is they've got a known seabed quality that they're dealing with, and they can just vibro hammer this in. And I believe they also use things like air curtains to reduce noise as well.
Hmm. Hmm.
Yeah,
Yeah. Okay. Okay. So you want this hole in the bed or the
yeah.
seabed, and then there's a huge big drill frame
Colossal
that
thing.
sits.
Yeah,
Okay.
yeah.
So how big is that drill frame then?
Uh, the bottom half was about 30 meters high. Yeah, it's
Hmm.
this is massive support structure.
Hmm.
500 mil diameter primary members.
Hmm.
Um, and then you've got all these drill tables that go up and down. You've got to supply hydraulic and electrical power to them from a ship. So this whole thing's got to be lifted off the back deck of pretty big ship,
Hmm.
a big jack-up rig,
Yeah.
and they've got to supply all the power down to the seabed to it, and then up the rig. And so what we did was we provided protection cages for the hydraulic and electrical power cables that go up and down with the
Ah,
tables.
okay. Yeah. Yeah.
Yeah, yeah,
Gotcha. Gotcha.
yeah,
And
yeah.
and all of this is submerged
All of
below.
this is submerged, and
Yeah.
it's comparatively shallow water. So what happens is you tend to get very high wave particle velocities with that.
Yeah.
So we're hitting our structure with 5 meters per second wave particle velocity. All right, which is quite significant. So we had to try and design something that allowed the waves to pass through, yet was robust enough to withstand and not flex under wave pressure.
Yeah. Okay. Okay. Yeah. Yeah. So almost aerodynamic in that sense to allow the
Almost, yeah, yeah, but
yeah.
I wouldn't want to see that fly.
Yeah. Or strapped to the back of a car.
Strapped
Yeah.
to the back of a fly. If I saw an airplane built like that, I'd be running.
Yeah. Good stuff. Okay. So the world's biggest hole.
Yeah.
I mean you've done you mentioned super yachts. I know
Yes.
that there are
Yeah.
some confidentiality issues with
Yes.
some
Yeah.
of the
Yeah.
stuff that you're doing, but
Yeah.
to go from a 9 meter diameter hole, massive drill frame
Yeah.
to a luxury yacht
Yeah.
is chalk and cheese, isn't it?
It is. But it's what I said to you earlier. It's all steel. It's only steel.
Yeah.
The only thing that changes is the environment you're putting it in and the standards you're applying it to.
Mm.
That's the only difference.
Yeah.
They're both still very niche, very interesting problems, engineering problems to solve.
Yeah.
And that's why we get out of bed to do this.
Yeah. Gotcha. No, good stuff. Good stuff. Yeah. Okay. I mean, I know again, there's lots more that I know you're involved with, but
Yeah,
client confidentiality is a big factor, of course, isn't it?
yeah, it is.
So perhaps if we start to think a bit more about simulation and FEA, obviously in terms of what you're doing.
Yeah.
So from a historical perspective,
Yeah.
and I don't know if I'm right in saying this, but even yourself, when we first started talking, there was a degree of skepticism around FEA
Yep.
as a design tool, as a
Yeah.
checking tool.
Yeah.
I mean, what would you say the thinking perhaps was in the industry, and where are you with it, or where is the industry with it now, would you say?
That's a very good question. Okay. Where do I go here? I think my personal view is by necessity, there has to be a certain degree of skepticism around a black box that is purporting to give you the answer. Because anything else, if you don't have that, you don't have a feel for the numbers, you don't have a feel for the behavior of a structure.
Yeah.
I think you're entering very dangerous territory.
Yeah.
Never, 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 never just accept the first answer that comes out.
I mean, again, one of the people I've spoken to on the podcast, and I've quoted this a couple of times with other people as well, is that the quote was, "Every model is guilty until proven innocent."
Yes.
Yeah.
Yeah.
And that's a good way of thinking, isn't it?
Yeah.
How much do you believe what you're seeing from an FEA tool? Yeah. Okay. Now, let me think. I mean, I don't want this to be too much of a leading question in terms of the software that you're now using.
Yeah.
But do you think perhaps some of the legacy FEA tools that people have been using didn't allow a sort of design freedom, and perhaps didn't allow visibility into what the structure was doing, to give you that warm feeling that the model is working, and you can, first of all, believe the results, and then use those results to either verify a design or make a design better?
For me, I'm not so sure it was that. I think it's more to do with the speed at which we can get to the point of running a simulation. Yeah, does that make sense? So
yeah.
A solver, a Nastran solver is a Nastran solver, whether you put it in Nastran, whether you put it in MSC Apex. A solver is a solver, and by and large, for the kind of work we do, they'll give us very, very similar results.
Yeah.
Okay. In the wrong hands, I think it's very dangerous. Yeah. So I would never advocate someone with zero knowledge jumping straight into FE and thinking, oh, yippee, we got it to run, and therefore it's okay. Where am I at? The earlier FE packages that we used to use were robust in as much that you could get them to mesh relatively quickly and get them to run if your geometry wasn't that good. But it could take you an awful long time in pre-processing to get a quality model to get the results out that you needed. And we found with earlier software that we did use, there was a real problem with generating that quality mesh and generating that quality model to get us to the answer that we needed to get to. And however, as we've progressed and we've invested in Apex, okay, I think I've mentioned to you in the past, I think it was like going from a skateboard to a Ferrari in one jump.
Yeah. I mean, in terms of timeframes, you take, you've built an Apex and Nastran model of your drilling rig. I've seen it. With your legacy tool sets, well, first of all, could you build an equivalent representation? And secondly, if you could do it, how long would it take you compared with the contemporary software approach?
The answer is yes, you could. However, to achieve the quality of the mesh and make the modifications at times that I needed to make through the life cycle of that project,
Yeah,
would have taken way, way longer. We'd still be doing it now.
so
That's perhaps a little bit glib, but
yeah, yeah.
you're talking, goodness, if I were to put a number on it, could I put a number on it? Not easily, but I'd say it's probably took 3 times longer than it needed to be. In pre-processing with the earlier software that we used to use.
So what you're talking, 2 or 3 days versus a couple of weeks or something like that?
Yeah.
Okay.
And and the nice thing is, with the Apex software, I've actually sat in meetings and people have just casually comment, "Oh, that's fantastic mesh. Love that. That's just really high quality."
Yeah.
And nobody's ever said that to me about the previous meshes I made on the other software ACs.
Yeah. Okay. What was I going to say? It's gone.
That's okay.
Okay. Yeah. So you've now got. Oh, yeah. I remember where it was. Yeah. Okay. So I've used legacy tools, and in the aerospace industry, developing some pretty, full wing models, full aircraft models.
Yeah.
And spending weeks, with teams of people trying to graph things together, and you often lose track of the point of what you're trying to do. You're so ingrained in well, you don't see the wood for the trees, do you? Basically,
no,
you're in the detail, but you've forgotten why you're doing it.
Yeah,
and it takes so long to get to some output. Any chance of design update at that then is going to be pretty minimal, because you've invested a lot of time.
It was awful. I mean, I can't tell you too much about it. We did a floating body a couple of years ago, about 2 or 3 years ago. I think the one I'm talking about is the one, and it wasn't and just the time it took to make minor mods or additions, to ensure full nodal connectivity was hours and hours and hours of manually dragging individual nodes. That's connected to that. It's just like, what are we doing here, guys?
Yeah. I do remember that model, and I think one thing perhaps we could say was that the structure was multiple meters, like 50, 60, 70 meters long.
Oh, goodness, yeah.
And the tolerance definition in the geometry was at the micron level, wasn't it?
Yeah.
Remember? So that caused an issue. You're trying to snap things together at that tolerance, accuracy, whereas the structure's humongous, So I do remember some of the issues you had with that. But equally, what once you've got the model set up in the contemporary manner, you can play games with it, can't you?
You can until it's time to modify the structure.
Well, that's what I mean. You can modify the structure.
And then additional mods would just take forever to develop, because it was just, again, you add new structure. Oh God, we're back to dragging nodes about, and
we're talking the old way of doing things here.
Yes, of course. Yeah.
But in the new
one, oh my goodness. And this is what I mean. It's like going from a skateboard to a Ferrari in one jump. And there's all sorts of the innovative tools in Apex that I absolutely love. There's no way I'd go back to anything else. To the speed at which we can generate geometry and mesh, high quality geometry and mesh, and know that it's properly connected, and know that the mesh is a very high quality before you even get to trying to get it to run. That's the game changer for us.
No, again, we've talked about a lot of these aspects. I mean, what would you say that having, I don't want to focus too much on the names of the tool sets or whatever, but just having a very contemporary FEA environment. What's that meant to your business?
It's transformative, because the kind of work we can do, if you're setting out to do cool stuff in our industry and solve difficult problems, well, the speed at which we can do it and the complexity of the problems, there's only so much complexity you can do in a hand calc. And there's only so much granularity you can achieve with a hand calc before you need to move to numerical analysis. And there's only so much warm, fuzzy feeling you can get from a hand calc for something very, very big and very, very complex. At some point, you've got to move to numerical analysis. You'll never progress. You'll never do anything more complex unless you can do it.
Yeah. Okay. I mean, just thinking there that there are many benefits here, but there's a benefit in the sense that you can effectively take on bigger, more complex work.
Correct.
Because you've got the capability to know that you can do it.
Yep.
And equally, if you're now doing it with the Ferrari and not the skateboard, there's a client benefit.
Yes.
That complex work that somebody else using a legacy tool set might not have been able to do. You come along, say, yeah, we can do it, and we can do it in a quarter, a third of the time, or whatever.
Exactly.
So that's a big deal, isn't it?
Well, it allows us to focus more on, and it comes back to your earlier point about losing your way about where you actually are in the process. It allows you to more easily zoom out and focus on the overall problem solution or the concept that you're trying to achieve, rather than, oh God, are all the nodes connected?
Yeah. You can do what if studies, can't you?
Yeah, exactly. And you're talking about the world's biggest hole in the job we did on that. We did an awful lot of what if studies on that.
Yeah. Gotcha.
Yeah.
Okay. So just looking at some of the things here. I mean, I know you've had some of your team, but I think you've been through some of the training as well.
I've been through some of the training. The training's fantastic that you do. Just a little plug for you.
we can edit that bit out. Don't worry.
Yeah.
You make me blush.
As endorsed by A Squared.
Yeah, but one of your guys, Kalpesh
has done a fantastic job.
Finished.
So that's right. And he's absolutely chewing his way through the non-linear stuff now. He's absolutely loving it, and he loves the way it's just broken down into bite-sized bits. So I mean, I've done a little bit of your training, and I thought it was lovely.
Can I ask, because I just focus on Kalpesh again because he's relatively new graduate engineer.
Yeah.
What formal FEA training had he done before, whether it's theoretical or practical? Where was he before?
That's a good question. I don't think he's actually done any. He's probably done a bit in his MSc. But like a lot of engineers, very often what tends to happen is you get put in front of the software and say, right, go ahead and learn it.
Yeah.
Up to a point, I don't think that's a bad way to do it, because I think most engineers are kinesthetic learners. They learn by doing rather than reading. And with this, it's about muscle memory, and it's about learning the process of FE. And getting that ingrained in you. I mean, my recommendation for anyone starting FE to learn a new bit of software is just take the same problem, do it over and over again. It'll get very boring, but you'll very quickly pick up the software.
Yeah, I mean, I'd add to that you always need to be verifying back to a hand calc or
absolutely.
It start small, build up complexity. Don't dive in. I mean, you've mentioned wave particle analysis and nonlinear structures. Don't dive in with that level of a detail straight away.
Oh goodness!
Build up to that, But that's definitely something that come on in time, isn't it? Okay.
Yeah.
So we've talked about the background to A Squared. We talked about some work that you're doing. We talked about some of the benefits that you're seeing using FEA in a contemporary manner. So, last question: What does the future hold?
Oh my goodness!
Where are you going?
Where are we going? Holiday soon, I hope. Where are we going? Right, we're growing. We have a growth plan that involves taking on, over the next 4 to 5 years, up to another 12 engineers. I want to see us in the realms of 15 or 16 engineers within 5 years.
Mm.
That's where I want us to be. Mixture of naval architects, structural engineers, and mechanical engineers
Yeah.
is where we're going. And it's a nice complementary mix of skills.
Mm.
And what we found since we got a mechanical engineer in the business last year, it's brought an unexpected but very pleasant dimension to the business that I didn't think we'd actually do. So it's opened doors for us. It's allowed us to do jobs that we never would have been able to do otherwise.
Yeah. Gotcha. Oh, it's pretty exciting, isn't it? You know,
absolutely love it.
That is getting you out of bed, isn't it? What does your LinkedIn strapline say? Something like the most difficult yet most enjoyable, or something?
This is the hardest but most fun thing I've ever done in my life, and it's true.
Yeah.
The troughs, when you get in a trough, it's pretty low, but it's counteracted by the highs are just astronomical.
Yeah. No, that's really good. That's really good. Thank you, Andy. Well, we've covered lots of things. Is there anything you wanted to talk about before we?
No. I think I've talked myself to death, Steph.
Yeah. Well, I've got a glass of water on the go, so you must have a sore throat.
But no, thank you for giving me this opportunity. It's been an absolute pleasure.
That's great, Andy. It's been great to talk to you. Okay, thank you.
Thanks, Steph.
Cheers.